Pneumatic tubes have been ferrying important items around and between buildings since the mid-19th century. Today, these tubular systems are still in use. Many hospitals rely on them to transport medicine documents and specimens around the building and to and from the lab in a matter of seconds. Between the walls of many hospitals lies a network of pneumatic pipelines, several kilometers in length. Specimens are first sealed in capsules before being given an air-cushioned ride to another part of the building. A computer allows the movement of the capsules to be monitored as compressed air whisks them through the tubing at up to 10 meters per second. Production starts with the send and receive unit. Tubes are first glued to a plate, both of which are made of plastic to reduce the buildup of static. The tubes are then slotted through holes in the top of the unit's housing. A pair of tubes is now placed inside the housing and are installed for them to move on. The tubes are slid back and forth to allow the system to switch between send and receive modes. For the sliding mechanism is now screwed to the unit's frame. The motor is then connected to a power source to confirm that the motion of the plastic tubes move. The source is connected to the system to check that the seals and vents are intact. At the next station, the unit's door is temporarily removed while the motor is the power source. The wires are bundled together with plastic ties, which are then trimmed. The computerized control panel is now fitted to the door, which can then be reattached before the control panel is wired up and tested. The computer in the send and receive unit is now connected to the one in the data unit. A test is performed to confirm that the two computers can communicate. There are numerous diverters in a pneumatic delivery system. These units allow the packages to turn corners or change direction within the network. A motor and gear are installed, and the movement of the pipe from one outlet to the next is tested. If all is in order, the back panel is screwed on. The diverter and other transfer units are then connected to tubing that runs through the walls of the hospital. To make the delivery capsules, a plastic body is placed in a fixture. A lidded cap is now added. The spinning motion also generates heat that fuses the cap to the body. The capsule is then slid onto a post. This prevents it from rolling around as the lid is connected to the unit with a spring. With the spring in place, the sliding lid is screwed to the framework. And the lid can now spring open and shut. A rubber casing is added to before a rubber gasket is stretched around the rim. Fabric bands are wrapped around both ends to help cushion the capsule during its journey through the pipeline. The bands are neatly tucked in. Plastic bumpers are also installed inside the capsule. These will help to protect the contents from any knocks and jolts during the ride. This medical capsule is now ready for a test run. Once inside the chute, its journey can be programmed. The door is opened to reveal the operation for our cameras. But the tubes slide over to collect the capsule and then slide back to drop it into the main pipe. And as compressed air blows through the system, it's gone with the wind. So there you go. We breezed through that last item, so it's time for us to take a short break.